All right, a couple quick things before we jump into this warm-up. So second day out of 3 that we have is to get ourselves ready for the test on Tuesday, so that you understand we're not putting pencil to paper on Monday as far as like working problems. We'll probably have a little quick warm-up, but the rest of the day Monday is where I'm simply going to give you a blank piece of paper and some colored pencils, and we're going to make what I will basically a cheat sheet. And we're going to go unit by unit, and I'm just going to say, okay, in unit 1, which is multiplying, dividing, exponents and variables, these are the things you need to keep in mind. Just 1 or 2 things from each unit. This is what you need to remember from unit 2. This is what you need to remember from unit 3. We're going to make a sheet that will list every concept I need you just to kind of keep in the back of your head for the test Tuesday morning. That's what I want you to look at between class time on Monday and the test on Tuesday, and that's the only thing I want you to look at. If you want to go home and work problems, you can, but I don't know that I necessarily would recommend it, because at that point you either have it or you don't. Now over the weekend, they're predicting like another crazy Saturday of storms again. So those of you that like play sports and stuff, more than likely you won't. So if you have some extra time over the weekend to do a couple of the ones online, do a couple of the ones online. You need the information fresh in your head when you walk in on Tuesday, okay? That's very, very important. So today and tomorrow, Luke, they won't until after it's done, okay? Yeah, the way that they work commended is a top percentage of those that take it. So it's like a moving target. They don't actually establish the commended rate really until everyone's taken it. So best thing to do is to score in the top 10%. That's about where it ends up landing. Okay? Yes, sir? I'm sorry, say that again. Drew. What were you going to say? Okay. So at the end of it all, the best thing, using today and tomorrow are the best things you can do to make sure you're ready. Use the weekend if you need to. It's just about comfort. It's about understanding when to do what. And more importantly, it's making sure that you don't read a question and instantly think you know how to get to the right answer. Pause for a second. And it's not just about finding a way to get to the right answer. It's about finding the smartest way to get to the right answer. Because a lot of times, the first way that comes to your mind may be the longest way to get there. And I'm going to show you examples of that in this warm-up. So number 1 says, write an equation slope-intercept form from the following table. I heard people talking about stat edit. Guys, stat edit is for line of best fit. It is not to be used as some blanket explanation on how to create an equation, because I'm here to tell you it works for this one, but it will not work for all of them. It'll give you wrong answers. So just know that, okay? What's the first thing you must find to write the equation of a line? Slope. Have to have the slope. No matter what else you choose to do, you have to find the slope. So in this case, we're going to do change in y and change in x. So 2 to 5 is plus 3, 5 to 7 is plus 2. This is 1875. That's 1250. Okay? So now we simply do change in y over the change in x to find our slope, and we end up with 18.75 divided by 3, which, Griffin, you're right, is 6.25. That's our slope. Now we only need what? Y-intercept. Now I want you to watch this, because a lot of kids don't think of this way to find the y-intercept, but this is the way I used to do it all the time. Because some of you will do the y equals mx plus b thing and plug in the m and the x and the y and manipulate the equation. How many of you did that? Okay. See who did this. Sometimes you can just put a table in. Put your x's and your y's. 2, 5, 7, 1750, 3625, and 4875. And if you understand the slope-intercept version of an equation, slope-intercept says that the y value equals the slope times the x value plus b, right? It's the slope-intercept form of an equation. Y equals mx plus b. Which means that if you take the x value and you multiply it times the slope, what's 6.25 times 2? 12.5. Luke Paley, how do you go from 12.5 to 17.5? you add 5. That's your y-intercept. That's your b. That's what you're adding to get to y. So you can do the same thing here, 6.25. 6.25 times 5 is 31.25 plus 5 equals. Guys, that means your b value is 5. You can back into it using the table. That means your equation is y equals 6.25x plus 5. And you didn't have to plug it in or manipulate an equation or anything. Just had to understand how it all works. Any questions on how to use this? Ryan? Okay, what were we going to say?
So if I found the common difference between 5 and 7 on the y, and I just subtracted.
You subtracted 1250 from this, didn't you? Yeah, that works too. Works too.
Well, not from that 7.
From the 1250 from 1750. I got it. So what Ryan's saying he did, he knew that the y-intercept is where the x value is 0. Well, to go backwards, it's minus 2. Well, he'd already established the change here was this. So from 1750, he simply subtracted 1250, and he got 5. It's another way to do it. Because the y-intercept is always where the x value is 0. Yeah. Lots of different ways to do what you're trying to do. What does the m value represent in this particular example? What does it represent in this example?
The amount of money per hour.
The amount of money earned per hour. It's his hourly rate. It's how much this person earns each hour. Slope will not be an answer choice. Okay? Hourly rate is what the m represents. And in the same scenario, what could the b value represent? Yeah. Okay, so maybe he had $5 in his pocket when he started working. Maybe his place of work gives him $5 a day plus $6.25 an hour. Maybe they give him a $5 bonus if he works a certain number of hours. It's basically something that doesn't change based off how many he works. That's what the b value could be. Any of those things would work. What wouldn't work is anything containing the word rate, right? Because it's not changing. It's not a variable amount. Okay, what is the slope of the line? 4x minus 3y equals 12. And then it says, what is the y-intercept and x-intercept? By the way, I would not have done this first. I would have done these two first. Because the y-intercept is where the x value is 0, and the x-intercept is where the y value is 0. And that's the best thing to use standard to form. Because the way standard works, to make the x value 0, we just make this go away, which leaves negative 3y equals 12. What would y have to be if negative 3 times something equals 12? Negative 4. And then to find the x-intercept, we make the y value 0. If we made the y value 0, 4x equals 12. Done. I would have done those first. Oh, and let me show you something else. To write the slope-intercept version of a line, what two things do you need?
Slope and intercept.
Slope and the intercept. So watch this. I'm not even going to manipulate that equation. I'm just going to take these 2 points, 0, negative 4, and 3, 0. I'm going to find the slope. 3, 4, the m value is change in y over change in x. I now have my slope. I have my y-intercept. Y equals 4/3 x minus 4. Lots of different ways to do what you need to do. I need you to begin to see different ways of doing things. Don't just rush into it and do it the exact same way you've always done it. Think about what you can use at hand. Oh, by the way, how many of you did the x and the y-intercept before you did the slope? Before you did this part? How many of you did these two before? Very good. How many of you did it in exactly the order that I put it on the board? You cannot do that on Tuesday. Because I'm here to tell you that on number 4 or number 5 or number 3, on that 54-question test, they're going to give you one that's going to kick the snot out of you. And when you read it, you're going to know it's one of those questions. It's one of those hard freaking number 3 questions that's going to kick the snot out of you. And you have to be willing to walk away from it. Walk right past it to the next question. And take all your good energy and all your I feel good about algebra and all your I got this test energy and invest it in all the other questions, but not those. Because on the test, there are going to be about 8 or 10 questions that are number 3, kick the snot out of you questions. And you should finish the test having not done any of them, the first run through. And if you do that, you'll finish the first run through in about 2 hours. Then you'll have 2 hours left to do about 8 questions. If you do it right. Okay? And we'll talk more about that on Monday. Let's go to this. Domain and range. There'll be 3 or 4 questions on domain and range on the test. Guaranteed. Guaranteed. So if you get domain and range, now a way to think about domain and range is this. I don't think about domain and range as X and Y. I think about domain as the measure of the width of a function, and I think of range as the measure of the height of a function. How wide is it for domain? How high is it for range? So in this one, when I'm measuring domain, it goes from here to here, which is from -3 less than or equal to x less than or equal to 2. That's your domain. Go ahead. And whenever I measure range, I measure lowest to highest point. So -2 is less than or equal to y is less than or equal to 4. That's how you measure domain and range. Domain is the width, range is the height. Okay? And make sure you're picking like the furthest points and the furthest points. So on this next one, the domain, what's the furthest left-hand point? -3 less than or equal to x less than or equal to furthest right? +3. Range, we do y's. Furthest bottom, lowest point, the lowest point, -2 less than or equal to less than or equal to +2. Lowest to highest, left to right. Now you notice I used equal to on both of them. There are 3 times where you don't use the equal to sign. Someone give me one. John? Open circle. Someone give me another. Anytime infinity is involved. Anytime infinity is involved, you can't use the equal to. You can only use the less than sign or use the all real numbers. Ryan? John said that. You also do it with discrete functions. Discrete functions can't use inequalities at all. Remember discretes where the dots are there? Make sure you're using brackets and listing them. Okay? So here we go. The domain on this, the left-hand point is -8, less than or equal to x, less than 7, not equal to. And the lowest to the highest is here to here. So -6 is less than y is less than or equal to 9. Now let me show you one other quick thing that I like to do. Check this out. What if on this graph it had a closed circle here and it went like this and then went like that and then went like this and then an open circle? Think about the range. What is now the lowest point of that range? -10. The range is -10 is less than or equal to y is less than or equal to 9. The open circle doesn't even come into play because the lowest point is here and the highest point is here. It goes right through the open circle. They like doing that kind of stuff too. So again, think of domain and range as left and right and low to high. Luke?
Wait, how does it go down that far?
Because I redrew it. I was saying, what if it did this? Got it? Shh. Would y'all stop it before I kill you all? Okay, so here's what you've got. You've got, I added 2 worksheets to the mixed drawer. The mixed drawer now has the third quarter review that we did. Third quarter review would have had everything units 1 through 7. So that's there. And a mixed review number 1 sheet, which is also 4 pages long. Okay? So 2 more sheets in here. If you haven't done the CMS Unit 4 assessment, I would strongly recommend it. I made more copies. All the answer keys are out except for the 2 new ones I just did, that I just mentioned, the QCA 3 review. and the mixed review, those answer keys are up here on this desk because it's just too many answer keys at this point. Okay, no?
All the answers.
Ready, set, go.
Ready, set, go.
Okay, go.